Okay, let us start. So today we are going to start off with a log function. Okay, so today I'm going to teach you how to use log to differentiate. So everyone, please write down differentiation of log function. Please write down differentiation of log function. So after that, please write down there is a function which cannot be differentiated without applying log, without applying log, and that function is of the form fx to the power gx. That means this type of function, everyone look at the board, fx to the power gx. So these type of functions cannot be differentiated before without applying log. That means the form of the function is called function to the power function. So if the base is a function, that means in terms of x or y, and if the power is also a function in terms of x and y, then if you have to differentiate this, you cannot differentiate this unless and until we bring the power in front, and to bring the power in front we have to use log. Is that clear? So once again, those who missed, listen to me. There is a function which cannot be differentiated without applying log, and which is of the form fx to the power gx, that is function to the power function. So whenever you see a question of this form, you have to apply log. Keep that in mind. Is that clear? Okay, so just below that, write down further. That means this is a short, that means you have to apply log for these type of functions. Is that clear? But there are some functions which can be differentiated easily by applying log. So I'm going to explain that also to you. So please write down further. In some cases, applying log will make the derivative very easy to differentiate. Very easy to differentiate. That is the function of the form under root u by v. So if you see question of the form under root u by v, then also we are going to use log. So I will explain in detail why do we use log, and why applying log makes the derivative easy. Is that clear? I hope you all are being able to see the whiteboard clearly. Yes or no, please?
Yes, sir.
Okay, fine. Okay, so once again, those who joined late, why do we use log? We use log for a special type of function, and that special type of function is a function to the power another function. That means fx to the power gx. So if you see this type of question, then you have to use log, otherwise you will not be able to differentiate. And the second says there are some functions which can be differentiated easily by applying log, and those are of this form, under root u by v. So I'll explain why using log the derivative becomes simple. Okay, so let me write down the properties of log. Property number one says, everyone, property number one says log AB, log AB is equal to log A plus log B. Log AB is equal to log A plus log B. Log A plus log B. Now you can easily see what is the sign in between A and B. This is multiplication. So if we have to differentiate, we have to use product rule. But the moment you see log, the product rule gets what you call separated. That means multiplication changes to addition. So you no more have to use product rule. That is why applying log makes the derivative very, very easy for many functions. Is that clear? Similarly, property number two says log A by B. So multiplication will change to addition. So obviously division will change into subtraction. So log A minus log B. If I tell you differentiate A by B, then obviously you are going to use quotient rule for it, isn't it? You are going to use quotient rule for it. But if you use log, then the quotient rule gets converted into subtraction. So you no more have to use quotient rule. So this is the main idea behind using log, to make the function simple to differentiate. The third one is log a to the power x. Whenever there is a power x, the power comes in front. So you get x log a, x log a. See, for example, look at this particular question. The reason why this question is difficult, it is because of two reasons. Number one, the square root. Square root means to the power half. So the moment you apply log, property 3 says the power comes in front. So you get half log u by v, isn't it? Next is the quotient rule. So property 2 says log a by b is log a minus log b. That means the reason why this question was difficult, that is because the power and the quotient rule both vanished. Is that clear? That is why applying log makes derivative of so many functions very easy to differentiate. But everyone, for now, for the while doing problems, just keep in mind that you are going to use log whenever the question is of the form fx to the power gx, and whenever you see under root u by v, these type of questions. For this, it's a must out here. Just it's up to you. Well, if you want to make the calculation simple, you can use log. Otherwise, you can do it in a what do you call the normal method also. But for this, you have to apply log. Is that clear? And the fourth property is the value of log e is 1. The value of log e is 1. So these are the four properties. These are the four properties on log. And everyone, the reason why I'm recording all the classes is, as I've already told you, this year the solution, the what do you call, the question paper is not going to be difficult, because it's all MCQ types. Okay, but the main thing is you need to understand each and every topic properly. So, like for instance, you are bound to get one question where you have to apply log. So if you don't have any idea how to differentiate a function by using log, then obviously you will not be able to do that particular question. Is that clear? So before I start solving the problems, the four properties will make the what do you call, the function easy to differentiate. So those who joined late, look at the first property, log a into b. So a into b, if only a and b was there, then I have to use product rule. So the moment you apply log, the product rule gets converted into log a plus log b. That means no more product rule. If I tell you to differentiate a by b, then you have to use quotient rule. But the moment there is log, log a by b becomes log a minus log b. No more quotient rule. Log a to the power x, the power x comes in front. The power x comes in front, so you get x log a, and the value of log e is 1. These are the four properties which you have to keep in mind. Okay, now we are going to start solving the problems. So before I rub this, please keep in mind that what type of functions are you going to apply log? Function to the power function. Keep that in mind. Okay. For example, everyone look at the board. This time, as you know, it's a MCQ type of question. So the questions are not going to be that long or difficult, but subtle questions which need concepts to solve. Look at the board, everyone. If someone tells you, let's like suppose the question is y equal to x to the power x, I have to find dy by dx. So if you don't have any idea, then you cannot differentiate this by using any formula. So y equal to x to the power x. So ठीक है मैं लिख दूँ. So y equal to x to the power x. This is the first question. Y equal to x to the power x. So you know how to solve this. This is function to the power function. So we have to apply log on both sides. So write down applying log on both sides. So you get log y equal to log x to the power x. Next, log y equal to, the main reason why I could not differentiate this was because of the power. And look at property number 3. Property number 3 says the power is going to come in front. So what is going to happen to this x? X will come in front. So you get x into log x. So see, the power has come in front. Now you can easily differentiate. Now help me out, everyone. Differentiating with respect to x. Log y. Log x is 1 by x. So log y will also be 1 by y, but since this is y, you have to write dy by dx equal to, what is the derivative of x? Derivative of x is 1 and the derivative of log x is 1 by x. But you cannot write down the formula directly because there is a multiplication sign. So we have to use product rule out here. So the reason why we applied log out here is to remove the power, because you cannot differentiate a question which is of the form function to the power function. So it has to be differentiated by applying log so that the power comes in front. Is that clear? So help me out with the product rule, everyone. What is the product rule? X d by dx of v, that is log x, plus log x into d by dx of x. So what is your answer? 1 by y dy by dx equal to x as it is. Log x, you know the formula. So this is called a standard function. No assumption required. So the derivative of log x is 1 by x plus log x, differentiation of x is 1. So see, x and x gets cancelled, so y goes up. So what is your final answer? Dy by dx equal to y into 1 plus log x. So this is the value of dy by dx, everyone. This is the value of dy by dx. You have to change the value of y. And what is the value of y? It is x to the power x. It is x to the power x. So please take a screenshot of this. So please take a screenshot of this. Okay. Now, since it's been many days that we are doing a systematic or step-by-step process. Now, since it's an MCQ question, you have to learn how to do the calculation directly also. Okay. So let us learn how to do it directly without applying the properties. Okay. The second question, everyone look at the board. The second question, the second question The second question is y equal to cos x to the power cos x. So I have to find dy by dx. Four options will be given. So could you please help me how to do this? This is again the same process, function to the power function. So we have to apply log. So when you apply log, what do you get? Log y equal to log cos x. What's going to happen to the power? The power comes in front. So I skipped one step out here. So you got cos x into log cos x. Is that clear? Now differentiate. Derivative of log y is 1 by y. And since it is y, you write dy by dx. So some students find it confusing as to when to write d by dx and when not to write d by dx. So please keep in mind that always in an equation there will be two variables. For one you have to write and for the other you don't. So how will you come to know for which variable you have to write and for which variable you don't have to write? If the variables are same, for example, I am differentiating with respect to x. So all the formulas that you are going to put for x, you are not going to write d by dx. But for y, you are going to write dy by dx. Why? Because dx by dx is cancelled, so you don't have to write. But this is y with respect to x, so we have to write dy by dx. Now help me out with the product rule, please. Help me out with the product rule. What does the product rule say? This is your u. So the product rule says the first term differentiate the second term. What is that? Log cos x plus log cos x into d by dx of cos x. That means this is product rule. For those who are seeing this for the first time, the rule is simple. You keep the first constant u, differentiate the second v, plus keep the second constant, differentiate the first. Now, when it comes to differentiating, ask yourself the same question. Do I know the formula for it? Yes, but even is standard. If I don't, then composite assumption gone parsa. So don't worry, I'll teach you that also. 1 by y dy by dx error. Cos x will remain as it is. अब इला differentiate गर्नु पर्यो नि. So think about the formula. Formula number 4 says log x हुनु पर्यो. But this is cos x. So what do? We assume this as x. So since we don't know the formula for this, this is called a composite function. So we assume this as x. So log x derivative becomes 1 by x. But this is just an assumption. So I have to differentiate this. So d by dx of cos x plus log cos x. You know the formula for cos x, that's formula number 7. So this is called a standard function, no assumption required. Cos x derivative is directly minus sin x. So see, cos x and cos x gets cancelled. We are not done because there's one more d by dx. So what do you get? 1 by y dy by dx is equal to, what is the derivative of cos x? Formula number 7, standard function, because we know the formula, we know the direct formula for this. So cos x derivative is minus sin x plus log cos x open bracket minus sin x. So what I can see is, I can see minus sin x common. So when I take minus sin x common, what do I get? When I take minus sin x common, I'm going to get 1 plus log cos x. And the y which was in the denominator goes up and becomes minus y sin x. I skipped one step. This value, y को value से लिखना पड़ता cos x to the power cos x. Is that clear? So if you understand the basics of calculus properly, then you'll have no problems when you do the remaining chapters. That means application of derivative is there. Then after that, application of derivatives. Then after that, what is there? Various methods of derivative is also there. So please take a screenshot of this. So you need to put the value of y. Okay. So right now we are doing systematically. Once you are confident enough, then you can skip few steps. Okay. For instance, you nagarda muntyo. That means I wrote down the property just to explain it to you. That means once you know that you have to use product rule, I could have directly written this. I could have directly written this. Okay. So then from here, that means the number of steps would be less. Okay. Please take a screenshot of this. This is question number 2. Okay. Next question. Next question. I'll just stop this. Okay. Question number 3 now. Okay, question number 3. Question number 3. Question number 3 says, if x to the power y equal to y to the power x, find dy by dx. I have to find dy by dx. Okay. Now everyone, look at the board. So again, out here, I have to use log. Reason, function to the power function, function to the power function. That means the power of x is y, is a function, and the power of y is x. So in order to bring the power in front, I have to use log. So we apply log on both sides. So what do you get? Log x, and out here log y. I'll skip one step. So log, this becomes what? X to the power y. So y comes in front. So you get y into log x. Similarly, log y to the power x. So x comes in front. So x log y. Is that clear? Now, since the power has been brought in front, now you can easily apply product rule out here. So please help me apply product rule for this. This is u into v. So I'm going to do it directly. Okay. So, or rather, this one also I'm going to teach you the steps, because some of you still might have problems understanding the property. So the rule is y as it is, differentiation of what? Log x plus log x as it is, differentiation of y, equal to the same thing, u d by dx of log y plus log y d by dx of x. Now, what did I tell you? The formula is same for, the formula is same for all the variables. It's just that you must be confident as to write d by dx. You must exactly know where to write d by dx and where not to. Is that clear? So I'm just going to help you all. So why, you know the formula for log x? What is it? 1 by x. We don't write d by dx because this is x with respect to x. So dx gets cancelled. So no use writing it. Plus log x as it is. Derivative of y is 1. But this is y with respect to x. So we have to write dy by dx. So 1 into dy by dx will give you dy by dx only. Is that clear? X as it is. If the differentiation of log x is 1 by x, then obviously derivative of log y will also be 1 by y. But since this is y, with respect to x different, so we write dy by dx plus log y as it is, derivative of x is 1. Since it is x with respect to x, we don't have to write d by dx. I hope now the concept of when to write d by dx and when not to write d by dx is clear to everyone. Now simplify. So when you simplify, I'll skip one step. You can see dy by dx two times. So bring them together. So you get log x dy by dx. So positive comes this time becomes negative minus x by y dy by dx is equal to log y. So positive y by x goes this time becomes minus y by x. So what is common out here? dy by dx is common. So you are left with log x minus x by y is equal to log y minus y by x. So take this one down. So what do you get? So dy by dx equal to log y minus y by x divided by log x minus x by y. So this is the solution. Is that clear? So please go through it, take a screenshot of it, and be ready for the next question. Okay, just to see whether you have understood or not, please try this. Y equal to 1 plus x whole to the power x. First, y equal to 1 plus x whole to the power x. This is function to the power function, so we have to apply log on both sides. Okay, so please. Answer कति आयो? Anyone with the answer? How much did you all get? Aditya? Dy by dx equal to, yes, correct. Dy by dx equal to y, open bracket, x divided by 1 plus x plus log, open bracket, 1 plus x. Very good. Okay, that is what you're supposed to get. Okay, those who did not get it, please let me know. I'll help you all. Okay, so let us move on to the fourth question. So I hope you have taken a screenshot of this. So we move on to the fourth question. So again, I'm telling you from calculus this year, everyone, try to means you need to have a basic concept of all the functions. There are various types of functions on calculus, which I've already explained in the first class. You need to have a basic concept of all the functions. Is that clear? So without wasting time, let us move on to the next question. Now we go to the fourth question. Everyone, look at the board. Okay, this is also a very important question for you all. Okay, question number 4, a 2-mark question. The question is y equal to sine x to the power x. I have to differentiate this. So dy by dx खोज्नु पर्छ. So this is not as simple as it looks. Ready, everyone? So derivative of y is what? dy by dx. Sineसँग के हुनुपर्छ? प्रयत्न. This has to be what? Meaning x हुनुपर्छ. If you are still having problems with this, please let me know. There's a video which you can refer. Or if you still have problems, I can explain it to you. So sineसँग x हुनु पर्यो. So sin x को derivative is cos x. But this is just an assumption. So d by dx of x to the power x. So differentiation of sine was not a problem, but what is the derivative of x to the power x? That is a problem. So can anyone tell me, how do you differentiate x to the power x? This is of which form? This is of a function to the power another function form, isn't it? So we have to use log, but see, we cannot use log both sides in the middle of the question. So what we have to do is we have to break this question into another question. Got it? So what just beside it, you break this question. That means take x to the power x as u. So u equal to x to the power x. Now, what do is you simplify this and get the answer. So when you differentiate or when you apply log, what do you get? Log u equal to log x to the power x. So the x comes in front. So derivative of log u is 1 by u, but this is u. So du by dx. Product rule, x, derivative of log x is 1 by x plus log x into derivative of x is 1. So x and x gets cancelled. So what is the value of du by dx? So du by dx, you are going to get 1 plus log x. So u comes up, so u, and the value of u is x to the power x. So you got this value. This is x to the power x. This is x to the power x. Now, see what do you get? How do you put the value? So this is what? This is x to the power x is u. So this is du by dx. So it's going to be cos x to the power x. And what is the value of du by dx? We already got that separately. You are getting it to be x to the power x, open bracket, 1 plus log x. So this is the value of dy by dx. Is that clear, everyone? So please take a screenshot of this. So this is the fourth question. This is the fourth question. Okay. Now, once you are done with this, we move on to the fifth question. So the basic idea has to be clear as to when to use log and why to use log. Okay. So the next question is, look at the board, question number 5. Question number 5. The question is x to the power, everyone just look at the board, okay? So this was an IAC question. The question was x to the power m y to the power n is equal to x plus y whole to the power m plus n. So this was the question. You have to find dy by dx. Hello? You have to find dy by dx. Okay. So everyone look at the board. So look at this. What is m and n? These are constant terms. So if you take m and n, the solution is exactly the same, but the question could be a bit long. So I don't think so that they are going to give a question of this form. So, but what they can do is they can replace m and n by constant terms, constant numbers. Is that clear? So if I write this as 2, if I take this as 2 and I take this as 3, then 2 plus 3, this will become 5. This will become 5. Now you have to differentiate. So everyone look at this properly and tell me, why is this question looking difficult? Because of two reasons. Number one is the power, isn't it? And number two is the product rule. Number two is the product rule. And you know, when you apply law, both the problems will vanish, because the moment you apply law, the power comes in front and the product gets distributed or removed. So you can do this in a much easier way by applying log. Is that clear? I'm not saying that you cannot do it in a different way, because I have already told you in the first class itself that there is only one what do you call compulsory criteria to apply log, and that is function to the power function. For that you have to use log, and for the rest it will just make the function simple to differentiate. Is that clear? You could have used product rule out here, still managed to get the answer, but the solution is going to be long. But the moment you use log, just think about what I'm telling. The moment you use log, the product rule vanishes. That means no more complications. The reason why this question is looking complicated is because of the power and the product rule. If you apply log, both will vanish. So won't the derivative become simple? So that is the concept that you need to understand. So everyone help me out. So when I use log, so I'm going to get log x to the power 2, product means what? Plus log y to the power 3 is equal to log x plus y whole to the power 5. That's the first step. So second step is going to be, what's going to happen to the power 2? The power 2 comes in front. So you write 2 log x plus, since it's MCQ, so you need not show the working. That's why I'm teaching you direct method. Is that clear? So the 5 comes in front. See, the reason this question was difficult was because of the power and the product. We have removed both. Now the derivative becomes so easy to differentiate. No complication at all. So we differentiate with respect to x every time, because you have to find dy by dx. So just keep in mind where to put d by dx and where not to put d by dx. Okay. So let's see whether you have understood or not. So 2 log x for derivative is 1 by x. यहाँ लिख देना, because x with respect to x, dx and dx काटिन्छ. Plus 3 log y equals 1 by y. Out here you have to write, because this is y. So dy by dx equal to 5. 5. Okay. 5 sir. अब यहाँनिर राम्ररी हेर्नु. प्रयत्न, look at this. Log सँग पनि खाली के हुन्छ? X हुन्छ. तर यहाँ x plus y छ. So we don't know the formula for this. So this type of function is called a composite function. So what do? We assume this part as x. So log x को derivative के हुन्छ? 1 by x. But this is just an assumption. So instead of writing d by dx, I simply have to differentiate this. So why not do it? So x को derivative के हो? 1. Y को derivative पनि 1 नै हो. But since this is differentiating y with respect to x, you have to write dy by dx. So see, d by d पनि हरायो. Now it's the only thing that is left for us is to simplify. So please help me simplify. के आउँछ? 2 by x plus 3 by y dy by dx equal to, look at this, 5 ones are 5. 5 by x plus y into 1 will give you 5 by x plus y, plus, because this being multiplied 2 times, 5 by x plus y into dy by dx will give you 5 by x plus y into dy by dx. So you see 2 dy by dx, one is on the left, one is on the right. So I need to take common. So if I bring this side, so obviously it's going to be negative. So I'm skipping one step. So if I take dy by dx common, 3 by y was already on the left, so positive. But when you bring this one to the left, positive becomes negative. So it becomes 5 divided by x plus y equal to 5 divided by x plus y was already there. So minus 2 divided by x. Now you just need to simplify this by finding out the LCM. So what is the LCM? Please tell me. Dy by dx. The LCM is x plus y and y. So look at this. The denominator is y. So you have to multiply the numerator with what is not there. That is x plus y. So when you multiply, what do you get? 3 into x plus y will give you 3x plus 3y. X plus y is there. Y is not there. So 5 into y. Do the same thing out here. So x plus y into x. So 5 into x minus multiply with 2. 2x minus 2y minus y minus because the minus sign in the middle. Okay, so now we are about to complete this. So see, x plus y and x plus y gets cancelled. So we are left with dy by dx, open bracket, 3x plus 3y minus 5y will give you minus 2y divided by y is equal to 5x minus 2x will give you 3x minus 2y divided by x. So see, 3x minus 2y and 3x minus 2y gets cancelled. So what is the value of dy by dx? Y goes up and x is left in the denominator. So the value of dy by dx is y by x. So this is how applying log makes the calculation very easy for us to differentiate. So the moment you look at the question, you must analyze it properly as to where does the problem lie and what could be the solution. So please take a screenshot of this. Please take a screenshot of this. Then we are going to move on to the next question. Then we are going to move on to the next question. Okay, the next question is okay. The next question is if y equal to under root 1 minus x and 1 plus x, if y equal to under root 1 minus x divided by 1 plus x, then I have to find the value of 1 minus x square dy by dx plus y equal to question mark. So I have to find the value of this. So you can easily make out that I have to find the value of dy by dx. And how do you find dy by dx? By differentiating this function. Okay. So when you differentiate this function, everyone listen to me, you get dy by dx, you put the value out here and then simplify and get the required answer. So there'll be 4 options, whichever matches the correct answer, that is going to be the right option. Okay, now look at this. There are so many ways in this particular sum can be done. It's on what matters is the length of the solution, and the shortest and the easiest is applying log. So the reason why, the first thing is the reason why I applied log is because of 2 reasons. Number one, square root. Square root means to the power half. So the moment you use log, the power comes in front. And next is a by b, quotient rule. Is that clear? If you use the normal method, how would you do? You would assume this as x. So root भित्र के हुन्छ x, root x को derivative 1 by 2 root x. But this is just an assumption. So dy dx of u by v, quotient rule चलाउनु पर्यो. It's not that you are not going to get the answer. You will get the answer, but in a complicated way. Is that clear? So I'm just teaching you technique so that you can your minimize your working. So please everyone, instead of memorizing the solution, try to analyze how you are going to solve a particular question. So the moment I look at a question, the first thing I do is I go for the difficult part. Why does this question look difficult to differentiate? So the easy answer would be because of the quotient rule and because of the power. And to remove quotient rule and the power, the only solution is log. So when you apply log, so see what's going to happen. So you get log y, okay, is equal to, I'm skipping one step. So you get what? Log 1 minus x, 1 plus x to the power half root. So half comes in front. So you get half. The half is for both. So into log 1 minus x. So instead of division, division changes to subtraction. So see, The moment you used log, the expression became so simple to differentiate. Now, no more power, no more quotient rule. Now, differentiate. What is the derivative of log y? It is 1 by y, but since you are differentiating y with respect to x, you have to write down the differential coefficient. You will never see an equation where there is no differential coefficient because dy by dx bhaneko nai, you are differentiating y with respect to x. So half as it is, the same concept, Nima, log by x. So log x derivative is what? 1 minus x, but this is just an assumption. So instead of writing d by dx, I can differentiate because I've circled it, means I have to differentiate it one more time. So differentiation of 1 is 0, x ko is minus 1, minus again log x. So 1 plus x, very I've circled it, that means I need to differentiate one more time. So 1 ko is 0, x ko is 1. So see what is left. 1 by y dy by dx is equal to 1 by 2. What is the LCM? The LCM is 1 minus x and 1 plus x. So out here 1 minus x is there. So you have to multiply it with 1 plus x. What should you multiply? What's the numerator? 0 minus 1 is minus 1. Minus 1 into 1 is minus 1. So you have to multiply minus 1 with 1 plus x minus 1 into, see, 0 plus 1 is 1. 1 into 1 is 1. So 1 plus x is there. You have to multiply with 1 minus x. So when you simplify this, see what you're getting. 1 by y dy by dx is equal to 1 by 2. So when you open the bracket, what do you get? Minus 1 minus x minus 1 plus x divided by 1 minus x, 1 plus x. Conjugate pair. A minus b, a plus b. The formula is a square minus b square. Is that clear? So you can see that x and x is getting cancelled. So you are left with 1 by y dy by dx is equal to 1 by 2. So x and x is getting cancelled. Minus 1 is minus 2 divided by 1 minus x square. So you can see 2 and 2 also gets cancelled. So what is the value of d? What is the value of dy by dx that you are getting? So your y cards answer mathi. So you are left with minus y divided by 1 minus x square. So this is the value of dy by dx which you are getting. Now, let me substitute the value. Let me substitute the value because you need to find out the value, isn't it? So let me do it out here. So everyone look at the board. So according to the question, I need to find out the value of 1 minus x square into dy by dx plus y. So 1 minus x square as it is, what is the value of dy by dx which you got? The value of dy by dx which you got is minus y divided by 1 minus x square plus y. So 1 minus x square and 1 minus x square gets cancelled. So you're left with minus y plus y, and that is equal to 0. So the value of 1 minus x square dy by dx plus y is nothing but it is 0. Nothing but it is 0. Is that clear? So once again, I'm telling you, please listen to me carefully. These are long answer questions which you have to understand in detail. So once I complete everything, because see, unless and until you understand the entire concept properly, you will not be able to do the easier ones, that means MCQ types. Okay, so once I complete the entire of derivative, so the entire of derivative consists of composite, log, parametric, inverse, L'Hospital, and second order. So the moment I complete this, then after that I'm going to do MCQ on all these topics, and you will see that whatever you are doing will help you a lot. Is that clear? So please take a screenshot of this. Please take a screenshot of this. So we move on to the next question. So can I just drop this? Okay. Now we just got few more questions to deal with. Then this particular topic, that means log, is done. If you want to practice more problems, I will be sending you a PDF which consists of solutions of lots and lots of questions that are to be solved using log. So the next question is, I forgot the number, so let it be. So the question is, this is also an ISC question. E to the power x plus y equal to xy, and I have to find the value of dy by dx. Four option will be given. Okay. So again, out here also, it's not that I cannot do the I cannot solve this without using log. I can, but the solution is going to be a bit complicated. So for example, out here I have to use product rule and I have to use assumption because the power of E has to be X. So the reason why this question is also difficult is because of the power and the product rule, isn't it? So why don't we make it simple? And how do I make it simple? By applying log on both sides. So when you apply on log on both sides, what's going to happen? Log xy will become log x plus log y. Product multiplication will change into addition. So now to differentiate, you need not use the product rule. Okay, so what's going to happen to x plus y comes in front. So you are going to get x plus y into log e equal to log x plus log y. Now you know the property of log, that the value of log e is 1. So log e is 1. So x plus y into 1 will give you x plus y equal to log x plus log y. Now help me differentiate this, everyone. So they are asking to find dy by dx. So obviously you are going to differentiate with respect to x. So what do you get? Differentiation of x is 1. Differentiation of y is also 1. But since this is y, we write dy by dx. Derivative of log x is 1 by x. Log y is also 1 by y, but since this is y, we write dy by dx. By now, I hope you are you the concept as to when to use d by dx and when not to write d by dx is clear to everyone. If you still have problems, please feel free to ask me. Now, what you need to do is we need to bring dy by dx on one side. So you get dy by dx dy by dx. So plus comes this and becomes minus 1 by y dy by dx is equal to 1 by x minus 1. Now what is common? Dy by dx is common. So we are left with 1 minus 1 by y. What is the LCM? The LCM is x. So 1 minus x. Do the same thing out here. Do the same thing out here. Do the same thing out here. What do you get? You are going to get dy by dx, open bracket y into 1 is y minus 1 equal to 1 minus x divided by x. So when you cross multiply, I'll just tell you verbally, when you cross multiply, the value of dy by dx is going to be y into, this is y into 1 minus x divided by x into y minus 1. So this is how applying log made this question very, very simple to differentiate. Is that clear? Okay. Now I will do one question where I'm going to teach you the limitations of log. Because see, you saw that when you apply log, that the function is becoming very simple to differentiate, but you cannot apply log anywhere. There are some restrictions to it. There are some restrictions to it. So I'm just going to explain that to you. So what are the restrictions? So everyone, so today's class was basically on application of log to make the function easy. And one special case where you had to use log was function to the power function. If you don't use log in this case, then you will not be able to differentiate. So please keep that in mind. Okay, so I'll just teach you the limitations of log, the last question for today. So please bear with me just a few minutes. Okay, everyone, just see this particular question. It is x to the power y plus y to the power x equal to 1. Now, look at this particular question properly. The moment you see this question, you must have realized that you have to use log because x को power y is a function को माथि function र y को power x function को माथि function. So दुईटै term लाई differentiate गर्नको लागि we need log, isn't it? But the problem out here is, look at the sign in between them. The sign in between them is a plus sign. The sign in between them is a plus sign. So if you apply log on both sides, then because of the plus sign, the log cannot be distributed. The log cannot be distributed. So what I mean to say is, what students do is they know that they have to use log. So what they do is they apply log on both sides. So when they apply log on both sides, the next thing they write is log x to the power y plus log y to the power x equal to log 1. But my dear students, this is wrong. The reason why this is wrong is because the property says the log gets distributed only if only if there's a multiplication sign. Only if there is a multiplication. Only if there is a multiplication sign, not when there is a plus sign. So in other words, what I'm trying to tell you is log a plus b भनेको log a plus log b होइन. So whenever there's a plus or a minus sign, we cannot apply log on both sides. So how do you solve it? Because you have to use log. अब applying log on both sides पनि हुँदैन अरे. So कसरी गर्छ भन्दाखेरि चाहिँ, since there is a plus sign or a minus sign between two functions, so the log does not get distributed inside. So what you have to do is you have to treat this as two different questions. So यसलाई u सम्झ x to the power x र यसलाई v सम्झ. So in CBSE you get these type of questions frequently. Okay, so you break this question into two parts. So solve it as two different questions. So how do you differentiate this? X has to be brought in front. So how do you sorry, x to the power y, how do you differentiate this? You apply log on both sides. So log u equal to log x to the power y, so y comes in front. So help me differentiate, everyone. Log u derivative is what? 1 by u du by dx equal to product rule. What will be the product rule? Y log x is 1 by x plus log x, y co derivative is dy by dx. So what is the value of du by dx that you are getting? So the value of du by dx that we are getting is y by x plus log x into dy by dx, open bracket. This u comes up and the value of u is x to the power y. So this is the first part of the solution. This is the first part of the solution. Now you have to do the same thing for v. So please help me out for v, everyone. Please help me out for v. So what do you get, please? Log v equal to log y to the power x. So this x comes in front. So derivative of log v is 1 by v dv by dx. Product rule. What is product rule? X as it is, derivative of log y is 1 by y dy by dx plus log y, derivative of x is 1. So what is going to be dv by dx? So dv by dx is going to be, v goes up. What is v? Y to the power x into x by y dy by dx plus log y. So this is the second solution. This is the second solution. Now you simply have to combine the two solutions. Okay, so how do you combine these two solutions? Look at this. The question is x to the power y plus y to the power x equal to 1, isn't it? So you have taken this as u and you have taken this as v, and this is 1 as it is. So when you differentiate with respect to x, derivative of u becomes du by dx. Okay, du by dx. Derivative of v becomes dv by dx, and derivative of 1 becomes 0 because 1 is a constant. Now du by dx is this, dv by dx is this, but that is not the end of the solution because you have to find dy by dx, isn't it? So dy by dx is in the first equation also, dy by dx is in the second equation. So what you need to do is, this is y to the power x. Okay, so what you need to do is First, you need to multiply. So x to the power y into y by x, keep it as it is, plus x to the power y into log x dy by dx. The same thing, y to the power x into x by y dy by dx plus y to the power x log y. After you do this, now equal to 0. After you do this, now keep dy by dx on the left and take everything on the right. So once you keep dy by dx on the left, then you find out the common, take dy by dx common. So once you have taken dy by dx common, then whatever is being multiplied with dy by dx goes to the denominator. Is that clear, everyone? So please go through these questions that are done today. If you have any problem, please ask me. And the video, the recording is also there. So everyone, listen to me carefully, please. These methods which we are doing are very, very important because it gets continued when we do derivative. Is that clear? So once I complete all the methods of derivative, this was the most important one, the composite function and the log. So what I want you all to do is, I want you all to keep on revising composite function again and again. The what do you call, the three video lectures. The first one where I've explained the formulas, the second one where I'm talking about standard and composite, and the third one is a difficult type of question. So I want you all to revise those three videos again and again, because if you do that, then these functions that I to come, log, parametric, you will understand it very easily. So once we complete all the 6 functions that are there in the syllabus, then I'll give you an entire set of questions containing only MCQ questions. So after you complete this, then you will find those MCQ questions very easy to answer. Is that clear? But without understanding the concept, it will be very difficult for you to answer the MCQ questions. That's why we are doing long answer questions also. We are doing probable questions also. Is that clear? So I want every one of you to go through whatever we did today, because the recording will come in an instant. So once you complete that, then be ready for the next topic that will be taught on today is Wednesday, so that will be taught on Friday, and Saturday and Sunday. I will complete the remaining topics also, because as I told you, only the composite and the log is a bit difficult one. So okay, everyone, good night.